Good afternoon, good morning, good afternoon, good evening, everyone. I am Zhang from the University of Canterbury. I feel good honored to be here to present our teamwork on a thrilling concept, situation awareness, known as SA, and its application on on-site safety management. As known to us all, wait a minute. Okay. As known to us all, the construction industry has been suffering from a high injury rate at the global level. To facing this challenge, we can see increasing research interest in applying digital technology, known as DT, for managing construction safety. For example, based on a literature review conducted by Brian Guo in 2017, up to 15 different types of DT were concluded in the construction safety field. The complexity and dynamics of construction sites challenge individuals' cognitive load and create information gaps between individuals and site conditions. In addition, the dynamic nature of the site can lead to a particular situation in which workers are often unaware of new hazards that emerge from interactions among activities and thus unable to predict possible hazards scenarios. Moreover, pre-activity safety planning is usually the focus of traditional construction safety practice. One deficiency of pre-activity safety planning is bridging the information and awareness gap caused by the site dynamics. As seen in the figure, the left and right side represent two situations with the vertical line in the middle as the dividing line. If we compare the climbing the ladder to a construction project, the right part signifies the imagination of supervisors, where every rung of the ladder was taken for granted. The left part symbolizes that some rung might be missing. Thus, the climbing task seems unachievable for frontline workers. In conclusion, the industry is eager for capable methods and DT to face dynamic construction sites. SA is a multi-dimensional concept that emerged from the military aviation domain during the First World War. The most widely accepted definition of SA is established by Edsley, the perception of the elements in the environment within a volume of time and space, the comprehension of their meaning, and the projection of their states in the near future. We are delighted to notice that several researchers have demonstrated the potential of SA to conceptually link DT and safety management and science. However, the mechanism of SA on safety behavior, site safety management process, and accident prevention strategies remain vague. SA is still an under-researched concept in construction safety. To fill the research gaps, we conducted a critical literature review aims to first identify and analyze current studies that integrate the concept of SA for managing construction safety. Second, investigate the conceptual linkage between SA, DT, and construction safety. Last but not least, recommend future research directions towards building a digitalized situation-aware construction safety management system. The systematic review method was adopted in this literature review. Due to the time limit, more information can be found in the paper. As can be seen from the figure, the number of SAA-related studies has been increasing since 2014. This corroborates our previous judgment on the potential of SA. The SA elements related to construction safety is just as cornerstone to buildings. The inner character of the SA element is a question of what are the essential data or information elements that enable an individual to develop an appropriate knowledge states for perceiving, comprehending, or predicting site safety-related scenarios. We did not discover a comprehensive set of elements of SA for construction safety. Instead, several studies attempt to link SA to specific aspects or objects of construction projects separately. From a construction safety management perspective, we categorize SA elements into three dimensions: people, machinery, and environment. SA elements of people can be further classified into physical and psychosocial aspects. Attention related to machinery assay elements is placed on location, behavior or motion, and machinery conditions. At the environment level, physical and psychosocial conditions are of interest for safety purposes. As we mentioned before, assay is a multidimensional concept. Numerous assay measurement methods were adopted outside construction domain. We are delighted to see researchers accelerate and strengthen those methods to better fit construction safety management. For instance, Fang and others developed a Cura-based assay measurement method inspired by situation present assessment method to quantify assay. Javier and Masood applied the goal-directed cognitive task analysis technique to investigate the key goals and assay requirements and develop assay-centered construction management methods and an IT tool to improve stakeholders' decision-making process. Plenty of DTs were utilized to measure, develop, and maintain assay at perception, comprehension, and projection levels to measure, develop, and maintain assay. However, construction projects usually have a very tight budget and timeline. Employing appropriate DT to maintain assay effectively and efficiently is a core pursuit. This pursuit motivates us to investigate the most suitable DT for our purposes. We have summarized a table to show previous researchers' understanding of the relationship between DT and assay. For instance, VR was adopted to investigate the impact of task intricacy on forklift drivers' assay. Ultra-wideband is an advanced real-time site object spatial data collection method. When talking about assay and safety behavior, identifying and testing antecedents based on existing behavior and motivation theories is a popular methodology for many scholars to study safety behavior. The literature does not identify any research that statistically tests the relationship between assay and safety behavior in the construction industry. However, Snaden demonstrates assay is significantly related to unsafe behavior in the oil and gas industry. Based on the survey data collected from multiple industries, Mohammed Fang performed a path analysis. The results suggest that the relationship between assay and human errors are statistically significant. Assay has been applied as a concept that links digitalization and automation in crane operation to safety performance. We have faith in the interconnection between assay and hazard identification. Key evidence is as follows. Eye movements can be a reliable indicator for workers' attention and the comprehension of construction hazards. Assay greatly depending on workload, state of the area of interest, and experience. The mental load will remarkably affect workers' assay. High production and coordination pressure might influence the stakeholders' response. Knowledge sharing and construction safety awareness are critical to hazard identification. To explain the mechanism of DT on safety performance, we propose a theoretical stance that DT do not improve safety levels directly. Instead, they improve the safety level by empowering people. Thus, the assay concept was suggested as a theoretical link to bridge gaps between DT and safety performance. We believe that delivering the right information to the right people at the right time is the crucial factor for accident prevention. To achieve this goal, we propose a coherent DT platform to provide a comprehensive situation picture, known as SP. The application of the concept of assay for managing construction safety is still in its infancy. Future research efforts should be focused on conceptualizing the role of DT in construction safety management and science. Based on the previous findings, we recommend the following research directions. First, research efforts are needed to identify elements of assay by levels, stakeholders, and tasks. Second, Based on the results from this research, an ontology or taxonomy of SA is needed to represent the knowledge of safety information in the construction domain. Third, as aforementioned, there is a need for research on investigating the statistical relationship between SA and safety behavior. Finally, future research efforts should be made to conceptualize the role of DT in accident prevention strategies. In conclusion, to promote DT utilization in construction safety management, we employ SA to link DT and safety management and science conceptually. The current conceptual position of SA in site safety was investigated by utilizing systematic review methodology. A comprehensive set of elements of SA for construction safety was not identified. As an alternative, SA elements were divided into 3 categories: human, machine, and environment. Several SA measurement methods was identified. DTs were classified by SA elements. The relationship between SA and safety behavior, safety and SA and hazard identification were examined. Furthermore, a coherent DT platform was suggested to deliver right information to right people at right time. 4 future research directions were recommended. Thank you for your patience. I hope you enjoyed the presentation. Here are the authors. Any question, please?